Students, this is the study guide for Test 5, which is on Chapter 8 topics. So number 1, we're starting with integrating 7 plus e to the negative 2x over e to the 2x. So this is like an 8.1 topic where you're trying to just basically determine what type of integration you're going to do. So I would split it up. Anytime you're dividing by a monomial, you can split up and divide each thing in the numerator by the denominator. So when you bring your e to the 2x up, it's going to become e to the negative 2x. And then when we do our second integral, we're going to subtract our exponents. So e to the negative 2x minus 2x would be e to the negative 4x. And now integrate each of those terms. So you don't really have to show a full u substitution, but you would use your u substitution on the exponent being negative 2x. So if your u is negative 2x and your du is negative 2, you're going to need a negative 1/2 in the front. So I'm going to pull out the 7 to the front and divide that by negative 2. And then you're just integrating like e to the u, and your u is negative 2x. All right, for your second integral, the exponent's negative 4x, so your du would be a negative 4, so you would need a negative 1/4 in the front, e to the negative 4x plus c, and so let's just write that as minus, obviously, instead of plus a negative, and there you have your answer. And of course, you would want to write this as negative 7 over 2 instead of a 7 divided by negative 2. All right, number 2, we have the integral of x to the 4th minus 9 over 16 plus x squared dx. Okay, so with polynomials in the numerator and denominator, you want to always look at the degree. And if your numerator degree is greater than the denominator, you want to do long division. So you're going to have to divide 16 plus x squared. And actually, you might want to rewrite that x squared plus 16. I think it would all work out, but we typically put our variables in order from highest to lowest. And then it's divided into x to the 4th. And then that minus 9, you know, you're going to have a lot of blanks. You have a 0 x cubed, basically, an x squared that's missing. You scoot it over even more. And then you have an x term that's missing. And then the minus 9. So when we divide x squared into x to the 4th, you get x squared. X squared times x squared plus 16 is x to the 4th plus 16x squared. Then we subtract. So minus, minus. So you're basically doing 0 minus 16x squared. And then, you know, you would typically bring down the 0x next, but you don't have to since it's 0. So you can go ahead and just bring down the minus 9 and then divide. So x squared divided into negative 16x squared is negative 16. Multiply negative 16 x squared, and then 16 times 16 is 256. So that's negative 256. Change your signs because you're subtracting. And then negative 9 plus 256 is 247. So that's your remainder. So this integral changes to x squared minus 16 plus 247 over x squared plus 16 dx. Okay, and so the first two parts are really easy. That's just your power rule. Negative 16, you just put an x on it. The last part, if you notice, is in the form of u squared plus a squared. or I should say du over u squared plus a squared. And that's going to be your inverse tangent. So you have that constant, 247, in the numerator, so that's going to come out. And then also you have to divide it, and y'all will have your formulas. So you're dividing it by a. That's part of the formula. And then you're going to have inverse tan. Remember, inverse tan is the same as arctan. So inverse tan of u over a, and my u is x, my a is 4. And then we have plus c. Okay? All right, so number 3, you're integrating negative 7x cosine of 8x dx. All right, and the specific instructions for that one says evaluate the integral using integration by parts. And so it's telling you to use integration by parts. So if you recall, you can use that shortcut Lipti on this one, otherwise known as the tic-tac-toe method. If you've never seen Stand and Deliver, just go to YouTube and type in tic-tac-toe method, or you can type in Stand and Deliver tic-tac-toe method. It's really neat. Came from a movie, but it's a real-life story about calculus. Okay, so with Lipti, you're looking at integrating a power and a trig function. Remember, this stands for logs, and then inverse trig is the I, P is power, T is trig, E is exponential. So we do have a power, it's just 7x to the first power, and then we have a trig function. So you can make your table with u, dv, and then the sign. All right, so your u is going to be the power, so that's the negative 7x part. Your dv is going to be the trig function, cosine of 8x. And then you leave the first blank space, or the first space blank, I said that backwards, for the sign. Okay, so on the u part, you take the derivative until you get to 0, so that's negative 7, and then 0. And then on the dv part, you integrate it. So that's going to be 1/8. The integral of cosine is sine. You know your 1/8 comes from u substitution. Then the integral of sine is negative cosine, so that's going to be negative 1 over 64, because we would have another 1/8 in the front. And then cosine of 8x. Okay, so you're skipping the first box for your sign, and then it just alternates between positive and negative. All right, and then you just do the diagonals, and so it's the product of these two, and then you use the sign right there, these two, and then that sign goes with that product. All right, so this is what we're going to have. Negative 7x times 1/8, that's negative 7 over 8x, sine of 8x. All right, and that was times a positive, so it's going to stay the same. So your next little group, you have a negative times a negative times a negative. So that's going to be a negative. And then you have 7 over 64, cosine of 8x. And, of course, our plus c at the end. Okay, so it's really easy to use. Once you've practiced it a few times, you should get the hang of that, the table method. All right, so the next problem, number 4. I forgot to number this one. You're integrating x to the 4th, natural log of 4x, dx. Okay, so using Lipti, let's see what we have. We have a power and a log. Now, one thing about the table method, you can only use it if your power is the u. Because, see, it has to go down to 0 for it to work. And so, in this case, our u is going to have to be the ln of 4x. Because, remember, with Lipti, you go in order So your L is going to be your U, and your power is going to be your dV. Okay, so our U, we can't use our table, so we just have to use the regular formula. U is natural log of 4x. Our dV is x to the 4th dx. du, so remember the derivative of natural log of u is du over u. So chain rule is here, so you have 4 over 4x, but that really just equals 1 over x dx, just for simplifying purposes. Then over here, you're integrating your dv. I usually do this a little bit neater. So the integral of dv is 1/5 x to the 5th. Okay, so let's recall our formula. uv minus the integral of v du. So our u times our v, I'm going to put the 1/5 x to the 5th first. And then natural log of 4x. And then it's minus the integral of v du. So v du is going to be 1/5 x to the 5th times 1 over x dx. So if you notice, that really is just going to simplify to 1/5 x to the 4th, which is nice. And so the integral of 1/5 x to the 4th, you just add 1 and divide by the new exponent. So that's going to be minus 1 over 25 x to the 5th. And then I'm going to bring down the other part of my problem. My 5s look like S's. I apologize. And, of course, your plus C. At least you don't have to worry about that with it being multiple choice. Okay? All right, so that was 4. Number 5. Hold on. We have the integral of e to the 2x times x squared dx. Okay, so looking at our elliptic, you have a power and you have an exponential. So you can use the table method. You have u, you have dv, and you have your sign. All right, so my u is the power, x squared. My dv is e to the 2x, and remember the sign, you just leave that off for the first box. Derivative of x squared is 2x. Derivative of 2x is 2. And derivative of 2 is 0. So we have to go to 0. All right, you're integrating the dv. So you would need a 1/2 in the front. 1/2 e to the 2x. So each time you're going to be multiplying by a half. So 1/4 e to the 2x. 1/8 e to the 2x. And then with your signs, you alternate between positive and negative going down. Okay. Then we do the diagonal. There's other methods of this box. I've actually seen students show me, other methods that their professors had taught them. So this is just the way that I learned it, and it works for me. So we have 1/2 x squared e to the 2x. And then the next one's going to be negative. So minus. So 2 times a 4th reduces to a half. And then we have that x in there. E to the 2x. Did not give myself enough room, so I'm going to go below. And then my last one's going to be a positive. 2 times 1/8 is 1/4. E to the 2x. And then plus c. All right, so number 6 is integral of e to the 2x times cosine of 7x dx. So if we do our lipd, we're looking at a trig and an exponential. So you're going to let your u equal the trig part, cosine of 7x, and then your dv equals the exponential part, e to the 2x, and see the dx goes with it. So the derivative of cosine is negative sine, so we need that 7 because of the chain rule. So negative 7 sine of 7x, and then we're integrating the dv part, so we need a 1/2 because of u substitution, also as a result of the chain rule. See how that works? And I forgot my dx at the end here. Sorry about that. Put a little line between them. Okay, so you're filling in uv minus integral v du. Change colors. Okay, so u times v is going to be 1/2. I'm putting the v first. E to the 2x cosine of 7x minus, and then we have the integral of v du. Well, it's minus a negative, so I think I'm just going to go ahead and change that to a plus right now to make it easier. And I have a 7 times a half, so I think I'm also going to put my 7/2 in the front. You don't have to do it this way. That's just makes it a little bit easier now going forward. Because see, now we have another parts that we have to integrate. So this is like called a repeated parts problem, and they're long. Okay, so we're going to do another part. So we have u equals sine of 7x dv equals e to the 2x dx. The du here is going to be 7 cosine of 7x. The v is 1/2 e to the 2x. Okay, so uv. Now remember, we still have this front term. I'm going to bring it down. And I also have this 7/2 that I factored out. So I'm going to put a bracket. So uv would be 1/2 e to the 2x sine of 7x minus the integral of v du. That's going to be minus 7 over 2 e to the 2x cosine of 7x dx. I forgot that. Sorry, I keep forgetting it, don't I? Okay, so this is really nasty, and you're probably thinking, do we have to do that again, another integration by parts? Well, the answer is no, and the reason is because this integral right here is the problem. They're just different coefficients. So those are like terms. You have to remember this is an equation. I didn't have room to write that, but I'm going to scoot this over. Maybe I can shrink it a little bit so you can see it. So I'm going to bring this integral down to the front. Let's change it to blue. So the integral of 2x cosine of 7x dx is equal to all of that. So this is an equation. So I can basically add this like term to the left side along with that integral. So if you think about it, you do have a 7/2 in the front. And that's another 7/2, but it's a negative. So we have a 7/2 times a negative 7/2, which is negative 49 over 4. And that's the coefficient of that term on the right side. And I need to add that to the left side. So I'm basically adding over here, 49 over 4 times the integral e to the 2x cosine of 7x dx. Okay, so that's 1 plus 49 over 4. Well, that's 4/4 plus 49 over 4, which is 53 over 4, times the integral e to the 2x cosine of 7x dx. Okay, so this kind of looks like a big old mess, but it is going to all work out in the end. All right, so what that's equal to is everything else. So the part in black that I need to bring down, that's the 1/2 e to the 2x cosine of 7x plus, and then I'm going to distribute that 7/2 to the 1/2, so that's 7/4 e to the 2x sine of 7x. So remember, we brought over that other term, okay? So it's gone. And so now basically, let me leave out the c, and I'll put that at the actual end. So we just need to solve for the integral of e to the 2x right here, this part. So what do I need to do? I need to get rid of that 53/4. So you're basically multiplying by the reciprocal of it. So 4/53. And this needs to be times 4/53. I'm telling you, this is not an easy problem. So you're going to end up with 2/53 when you simplify. E to the 2x cosine 7x plus, and then the 4's cancel, so I think 7/53 e to the 2x sine of 7x, and then plus c. Okay, so that's how you do a repeated integration by parts. All right, number 7. I think I'm going to go to a new page for that one. You're integrating dx over x squared plus 25 to the 3/2. Okay, so this part starts the trig substitution part, and it tells you in the directions, use trig substitution. So this is where you're going to have a triangle, and you will also have your formulas for this on your formula sheet. You have your right triangle with theta. And you're going to look at what type of problem this is. If it involves, basically a plus, an x squared or an a squared plus u squared, that's going to be inverse tan, okay? Or that's not inverse tan, excuse me. You're going to be using the formula that has let x equal a tan theta. So identify like all your little parts here. You have your u squared plus a squared. So what is our a? Our a would be 5. It's the square root of 25. So x would equal 5 tan theta. And it makes sense because if you divide by 5, the tan theta equals x over 5. And tan is opposite over adjacent. So your triangle would have x on the opposite and 5 on the adjacent. And then your hypotenuse would be the square root of x squared plus 25. And that's that square root you have on the bottom. All right, so now you're going to replace everything, with the stuff in your formula or on your formula sheet. You have to do the dx. So the derivative of tangent is secant squared. All right, and then you also want to know what your square root is going to be replaced by. You can get that from the triangle, or you can just get it from, I think the formula sheet also has it. Of course, they don't use, x squared plus 25. They would use like u squared plus a squared, I think. I don't have that formula sheet sitting right in front of me. All right, but if you look and see, the secant theta of that triangle would be the square root of x squared plus 25 over 5. And so they're just solving for that x squared plus 25 part to get it in terms of secant theta, okay, or whatever trig function it is. So substitute everything in now. So you have the integral. The dx is 5 secant squared theta d theta. All right. the bottom, it's the square root to the third power. So what you're doing basically is you're cubing this. And if I cube both sides, you're going to have 5 cubed, which is 125. And then secant cubed theta. Okay? And so now you can cancel secant squared. So you'll have a secant left on the bottom. And then 5 goes into 125, 25 times. So let's see, we'll have d theta over 25 secant theta. Well, let's flip that and call that cosine. So that's really the integral of 1 over 25 cosine theta, d theta. Of course, the 1 over 25 could go to the front. And that is just 1 over 25 sine theta plus c. And you cannot leave your answer in terms of sine. We need to get it back in terms of x. So you go look at your triangle and you say, what is sine of theta? Well, sine is opposite over hypotenuse, O over h. This is why you had to take trig. And so we're going to have 1 over 25 x over the square root of x squared plus 25 plus c. Okay, so number 8 is going to be another one of those. So we have the integral of dx over x squared times the square root of x squared minus 64. So let's draw our triangle. All right, so when you have u squared minus a squared, you're going to let the x equal a secant theta. And so our a is 8, square root of 64. And this is because the secant of theta would equal x over 8 if you divided both sides by the 8. And if you remember from trig, secant being the reciprocal of cosine, that's going to be like the hypotenuse over the adjacent. So when you draw your triangle, that means that your hypotenuse is x and your adjacent is 8. And so then that missing side gives you the square root of x squared minus 64. If you were solving for that missing side, okay? So you do your dx. So the derivative of secant is secant x tangent x. So this would be 8 times secant theta tan theta d theta. All right, and then you figure out what your square root is. So you can just use your formula sheet, or if you think about with your triangle, basically it's like isolating that radical. Well, if you did the radical divided by 8, that would give you tangent theta. So it's 8 times tan theta. Okay. So now you can like fill in all of your pieces of the integral. I forgot my integral symbol. So we have the integral of 8 secant theta tan theta d theta over your x squared is going to be 64 secant squared theta. That's just squaring this formula right here. Okay, and then your square root is 8 tan theta. All right, I'm going to kind of underline that with green so y'all can maybe see that. Underline the x squared with blue. Go back and circle that in blue. And then your dx, I'm going to circle with yellow, just so you can kind of see all the different parts that were put together. Okay, so simplify. Let's see, we can divide 8 into 64. That's easy. Oh, and actually, we could just cross those 8s. Secant theta, one of the secant thetas on the bottom will cancel. Tan theta and tan theta. So you're left with 8, or no 8. You're left with d theta over, on the bottom, we just have 64 secant theta And so the reciprocal of secant is cosine. So this is 1 over 64 integral cosine of theta d theta. So it's similar to the last one, actually. Very similar. The integral of cosine is sine. And then you want to go back to your triangle because you're not going to leave it in terms of theta. You have to get it back into x's. So the sine of theta is the opposite over the hypotenuse. Squared x squared minus 64 over x. And then plus c. And the 1 isn't going to be written. The 64 is going to be, by the x. So that's just normal. You'll notice it with the multiple choice. All right, number 9 is the integral of x cubed over the square root of x squared plus 7. See, these are problems you cannot traditionally solve with regular integration methods. So that's why we use the trig substitution, because what happens is it ends up letting you cancel things out, and it puts it into something that is integrable that you can basically figure out. And it's all, it's all trigonometrically correct and algebraically correct, because you're just using, a right triangle. And you're putting everything in terms of theta instead of x's. Okay, so we have, looks like inverse tan, and I keep saying inverse tan, and I apologize for that, but we're going to be dealing with tangent. Those are easy to recognize because of the plus. They're the only ones that have u squared plus a squared. So the square root of 7 is going to be that a. It's not a perfect square this time. Usually it is, but this one's just kind of weird. Derivative of tangent, secant squared, theta, d theta. Okay, so then our square root of x squared plus 7. So if you set your triangle up, the opposite is x, the adjacent is square root of 7. The hypotenuse is the square root of x squared plus 7. And see, that would equal the square root of 7 secant theta. Okay. All right, so now we're ready to fill everything in. So our x cubed, we're going to have to cube both sides of that equation. Or you could actually just put in the square root of 7 and then tan theta. Let's go ahead and call that cubed. So what happens when you cube the square root of 7? So if I had square root of 7 times itself 3 times, so the first 2 would just give you back 7, and you would have an extra 7, or square root of 7. So let's do it this way. On the bottom, you're going to have the square root of 7 secant theta. And don't worry, I'm not forgetting it. My dx. This is why it's so important to use, the correct notation when you're working problems. Because a lot of students, they're kind of lazy with integration. They don't put the dx, or they forget it a lot of times. But this is one section where if you forget it, you're just not going to get the problem right. See, that dx has to be filled in. It's just like u substitution. You're filling in every little piece, changing your variable from x to something else. And in this case, we're changing our variable from x to thetas, and so our dx has to be something in terms of d theta. Okay? All right, so what can I do here? Looks like all I can do is cancel one of the secants out, and I can do the square root of 7. I'm going to pull this 7 square roots of 7 to the front. So I'm integrating tan cubed theta and then secant theta d theta. All right, so this is a little trick you have to know also. It's not the easiest thing in the world, but it looks like we can use some kind of u substitution here, and this also was another section. in y'all's notes where you have to take one of those tangents out and put it with the d theta. And so I'm going to instead have a tan squared here. And then I'm going to have a secant theta tan theta. I think we usually do it with sines and cosines, but it also works, you know, with tangents and secants as well. So you're looking at the fact that if I replace that tan squared with something in terms of secant, I can then have my du. I'm going to use some u substitution here. So you have the Pythagorean identities. Tangent squared theta plus 1 equals secant squared theta. If I solve for tan squared theta, I'm going to get secant squared minus 1. So you're just bringing that 1 across. Okay, so see this out to the side. I'm just going to underline it with yellow. This is all going to be part of that du. So I'm going to do like a u substitution. Okay, let me bring my integral symbol down. 7 square roots of 7. So on the worked out key, I have 49 over the square root of 7. It's the same as 7 square roots of 7. If you rationalize your denominator, that should come out the same. So now we're going to let u equal secant theta. Du is secant theta tangent theta d theta. Okay, so that is what I have over there. I can replace that with a du. So think of what your integral is going to be. U squared minus 1. And then times du. So you have to remember, though, you're integrating with respect to u. So when I integrate this, my answers are going to be with a u. So that's going to be 1/3 u cubed minus u plus c. Okay, so let's see. We're going to have 7 square roots of 7 over 3. The u was secant theta, so I'm going to put my secant theta back in place. So it's secant cubed theta minus 7 square roots of 7 secant theta. That's just replacing that u plus c. We're still not done because we have to go back to our triangle now, or you can just use actually the formula where we had secant theta right here. So if you divide that by the square root of 7, so we have square root of x squared plus 7 over the square root of 7. If I would have known how hard this problem was before I assigned it, trust me, I would not have assigned it. And I really do believe y'all don't have one of these on the test, so I don't want y'all to worry about one like this. But let's just keep going since I've gotten this far with it. All right, and then especially horrible because of the square root of 7. All right, so square root of x squared plus 7 to the 3rd. So you're going to have, I think we're just going to write that to the 3/2. So you would have the square root of 7 cubed. So that would cancel, and I believe actually that whole thing would cancel, because the square root of 7 cubed was 7 square roots of 7. So all you're going to be left with would be a 1/3 in the front. Then that's going to cancel. So minus 7 square root of x squared plus 7 plus c. Okay, so I just looked at the answer key, and that is correct. The only difference is the answer key had the square root of x squared plus 7 to the 3rd instead of writing it to the 3/2. So that's just some, algebra. So I think that's okay. All right. Hard problem. Number 10. Integral of 1 over t squared times the square root of 8 minus t squared dt. Okay, so let's do our triangle. So it looks like we have the a squared minus the u squared situation, and so that's going to involve sine. So we're going to let t equal, and it's the square root of 8. Here again, not a perfect square, times sine theta. And so if you set your triangle up, sine is opposite over hypotenuse. So your opposite is t, hypotenuse is square root of 8. And then you have the square root of 8 minus t squared. Okay. Our dt, the derivative of sine is cosine. Theta, d theta. And then our square root is going to equal the square root of 8 cosine theta. And that's because cosine's adjacent over hypotenuse, and so they just solve it for the adjacent side. So filling everything in, we're going to have the integral of dt, that's going to go on the numerator, over your t squared. When I square my square root, let's do that out to the side. So when I square that, I'm going to get just 8 sine squared theta. And then replacing your square root is the square root of 8 cosine theta. So let's do a little color coordinating again. So your numerator, that was all your dt. And my denominator, my t squared, is going to be this front part. I'm just going to circle that with the yellow. And then in blue, I've got my square root part. So square root of 8 cosine theta, which came from there. Okay. We can cancel square root of 8. We can cancel cosine theta. It's always wonderful to cancel things. So you have the integral of d theta over, we still have an 8 left, and a sine squared theta. All right, so let's think about this. So the reciprocal of sine is what? Cosecant. So I think the integral of cosecant squared is going to be a straightforward deal, if I'm not mistaken. So we have 1/8 integral of cosecant squared theta, d theta. Okay. And I believe it's the derivative of cotangent is negative cosecant squared theta. So we are missing the negative, but this is just a straightforward integral you should have on your formula sheet. So negative 1/8 cotangent, and it's not squared, it's just cotangent theta plus c. Okay. And then you're just going to go back to your triangle and figure out what your cotangent is. So the cotangent is the reciprocal of tan, which is O over A. And so this is going to be A over O. A is adjacent, O is opposite. So my adjacent is, let's see, we're going to have a negative square root of 8 minus t squared over 8 times the opposite, which is just t. So I'm going to scoot that over a little bit. So over 8t plus c. They may put the negative 1/8 in the front. I'm not sure. I don't know. This is the way I have it written on the answer key. So that looks right. All right, so we have one more of the trig, and then I'm going to do a separate video for partial fractions. So number 11, square root of 81 minus x squared dx. So this looks a little straightforward, actually. So you've got a squared minus u squared. So you're going to let x equal a. So this time we do have a perfect square, yay. So 9 sine theta dx is 9 cosine theta d theta. All right, so setting up my triangle, my opposite's x, my hypotenuse is 9, my adjacent's going to be that square root. So that means that my square root is going to be cosine. Okay. All right, so all you have to fill in on this one is your square root and your dx. So 9 cosine theta times 9 cosine theta d theta. So I have the integral of 81. I'm going to pull that to the front. Cosine squared theta d theta. Okay, so this one, I think it's on the formula sheet. It says on the study guide, use formula sheet. So you should have the integral of cosine squared theta. It goes directly to, let's see, 81, 1/2 theta plus 1/4 sine of 2 theta plus c. All right, the problem here is that your angle sine of 2 theta, you're going to have to figure out that. You can't use 2 theta because our triangle is theta. So we're going to have to use a double angle formula, which is also on your formula sheet. That comes from trig. Sine of 2 theta equals 2 sine theta cosine theta. All right, so we have 81 times 1/2 theta plus 1/4, and I'm replacing that sine of 2 theta with 2 sine theta cosine theta. Okay, so now I've got 81 over 2, just distributing that 81 out. If you look back at your triangle, you're going to write theta in terms of, you know, what that angle represents. So it's the inverse sine of x over 9, or the arc sine. So 81 over 2, arc sine of x over 9. They could use something else besides arc sine. They could use arc tangent or arc cosine of that triangle. However, that's the easiest one because the x and the 9 are just the easiest, most simple expressions on your triangle, your opposite and your hypotenuse. So arc sine of x over 9, I'm assuming that's why they use that. I never have researched it or anything, but that makes sense to me that that's the simplest. And then plus 1/4 times 2 is 1/2, and you have that 81 still in front. So that's going to be 81, let's see, over 2 also. And then sine of theta, remember, is x over 9. And then cosine of theta is adjacent over hypotenuse. Okay, so the 81 and these 9s are going to cancel. So you're going to have 81 over 2, arc sine of x over 9, plus x times square root of 81 minus x squared over 2, plus c.